This is section 3.4, day 1, and today we're going to start talking about solving slightly more complicated exponential problems. So the ones you've done so far have kind of been straightforward, maybe a step or two, and they usually are matching bases and exponents in some form. Now we're going to get into ones that are slightly a little bit more messy. So the first one, we've got 2 to the x, and then we've got 8 to the x minus 2. And I'm hoping that you can see that 2 and 8 are related. Not exactly in the same family yet, but they're definitely related. So I'm going to take this 2 to the x, and I'm going to rewrite this 8, just the 8, and I'm going to rewrite it as 2 cubed. So I'm just replacing 8 with 2 cubed. That x minus 2 is still in the exponent. That still comes down and hangs out up in the exponent. Now that I've got these two bases to match, which has kind of been what we've been gaming for this whole unit so far, if I can get those to match, then the exponents have to be equal. And now I just have an algebra problem. So distribute my 3, move my x's over, and divide. So started off with what looked like kind of a difficult exponential function or equation, and then we just kind of switched it to where the bases match each other, then our exponents can be equal. In the next one, when we have quantities to an exponent like this e, I tell kids try and think of this as just one quantity. This is one whole thing. So think of it as just one piece, and you've got 5 times it minus 8. So algebraically, the first thing we would do is add the 8. And then algebraically, we would divide by 5. Whoops, 8. So we've got e to the x plus 2 equals 4.4. Now the only way that we can actually get this exponent down, because that's where the variable is, so the only way we can get it down is if we have a log. And I can pick any log in the world, but the log the log that fits e the best, is how I should have said it, is if I would take natural log of both sides. So as soon as I put that natural log down, I just have to do it on the other side, and then I'm still maintaining mathematical equity. So my adding 8, or dividing by 5, I can natural log both sides as long as I do it to both. So these will cancel. I'll be left with x plus 2 equals natural log of 4.4. And that's about 1.48. And then I'm just going to subtract the 2 over. And so I end up with about negative 0.52. Next up, I've got a fraction. We've talked about these a couple of times. It's difficult to solve when you have one side's a fraction and one side is not. So we kind of need to make these be the same. So I'm going to flip this fraction over. It's going to become 3 over 1. And when I do that, that switches to a negative exponent. All I have done so far is just switch the fraction. That x is still up there, so that's got to come with. Equals 9. Now I can tell that 3 and 9 are related. They're pretty close, actually. 9 is really just 3 squared. So as soon as I get these two bases to match, then the exponents have to match, and x is negative 2. A couple more to go. This looks a lot like number 5. The only difference is instead of being an e, we have a 3. So we're going to start by adding 4 and then dividing by 2. Equals, and that'll be 2.5. What usually happens here, a couple of things that students do that won't work algebraically, is they try to distribute this 2 in here. So inside this quantity, kind of think of it as a protected little quantity, and you cannot get things in there or take things out. It just sits as one quantity until you get it by itself. So distributing that 2 says that the 2 is also carrying this power, but it's not. It doesn't, well, its exponent is 1, but it doesn't carry an exponent to match. At this stage, I will have a lot of students say, well, I'm going to divide by 3, except for this 3 is tied into this exponent. And the only way to deal with exponents in the unit we're in right now is with a log. So I can't just divide the 3 off and think that that's just going to slide down in place. I first have to have a log. Up here we had an e, so we chose natural log because that was the bestest fit. Down here I have a 3, so I'm going to choose log base 3. That is the best fit for what I've got. A log base 3, kind of sneak that in. Again, it doesn't matter what log you pick. You could have picked anyone in the world. That's just the best fit because then those two will cancel, and I'll be left with 2t minus 5 equals log base 3 of 2.5. And now this side is just a change of base formula, which we have done before. So log 2.5 divided by log 3, which is about 0.83. And then to finish this off algebraically, I will just add 5 and then divide by 2. So we end up with about 2.92. Next one kind of looks like number 1, like we've got some stuff with exponents on both sides, not too complicated looking. The problem is that 2 and 3 are not related. I can't get 2 to look like a 3 and vice versa. So we're just going to start this one off by choosing a log to use. I need to get those exponents out of, the variables out of the exponents. The only way to do that is to drop it down. And I can only do that if there's a log in front. So you're going to kind of pick your poison on this one. Do you want to do log base 2 to both sides? And one side will be nice. The other side will need a little bit of work. Or you can do log base 3. This side will be nice, and this one needs a little bit of work. I'm going to choose log base 3 because it's got the more complicated exponent. So I'm going to do log base 3 of 2 to the x and log base 3 of 3 to the x plus 1. So on the right-hand side, those will cancel. That's nice. I've just got an x plus 1. Over here, the x will come in front, and then I've got a change of base formula. So doing log 2 divided by log 3 gives me about 0.63 equals x plus 1. So I'm going to subtract this 0.63 over. Remember, that's just a 1x. So I'm going to do 1 minus that 0.63, which gives me about 369. I'm going to move that negative 1 over at the same time. So 0.369x. And then we just have to divide. So negative 1 divided by what we got. So about negative 2.71. Oops, sorry, you didn't see that. Last one looks a little more complicated. It actually has 3 different terms in it, which is not very cool. I really can't just add 20 because I've got 2 different types of e's here. I've got an e that is squared, and then I've got an e that is just an x. If I had written the problem like this, though, I think most people would have said, well, do the quadratic or your favorite F word, which is factor. That's the one we're going to tackle. So we can factor e's, and they actually work the exact same thing as or exact same way as x's. And I often advise kids, just write it like this. Take the e's out. That's an x squared, that's an x, that's a 20. And let's just factor that. So to get to 20, I have to have 2 things that multiply. So 5 and 4, 2 and 10, 1 and 20. The only one of those that would get me to a negative 1 is 5 and 4. For me to be negative, my biggest number has to be negative. And then instead of an x up front, we're just going to be an e to the x. So that's the only thing that changes when you are factoring a function that has an exponent in it. And now when you were little and you factored, what you did was you took each one of your factors and you set them equal to 0 so that you could find your answers or find your answers. Sorry, find your answers or find your solutions. That's the end of the day. Okay, add 5 to both sides. The only way we can get rid of an e is to ln it. So I'll ln both sides, and on this side I get ln 5, which is about 1.61. Looks good. This side I would subtract 4, so I have e to the x equals negative 4. And then when I ln both sides and get ln of negative 4, I get an error. And the reason why your calculator cannot do the log of a negative is because, do you remember what our graphs looked like? The log functions don't end up on that side unless we move them, like if we slid it to the left. But at its base, its parent function doesn't even touch the negatives. So I can't take the log of a negative number. So that is your first day of solving slightly bigger equations. You're trying to get the thing that has an exponent isolated so you can log it. Whether it looks like this and you gotta do a little algebra first to get it isolated, or you are switching one of them so that they match bases.